Hey guys, it's Miss Adams, and we're still looking at our Unit 7 review, or Unit 6 review, sorry about that guys. And we're gonna flip to the back side, so we're looking at problem 8, just finished problem 7. And let's read through this. It says, this year there are 2,457 elephants in southern Africa. The elephant population increases at a rate of 3% per year. We need to write an exponential growth or decay model for the population after X years. Well, in order to know what type of model, we've got to read through our context clues here. And it says the elephant population increases, so therefore this is going to be a growth model. The formula for growth is y equals a multiplied by 1 plus r to the x power, where my a value in this case is my initial value, so that's the amount of elephants that we start with. And my r value is going to be my rate, which is given at 3% each year. But I can't put this rate in as a percent. I've got to convert it to a decimal. So I've got 3 divided by 100. That's going to give me 0.03 for my rate. So my model here is going to be that y is equal to the initial value of 2,457 elephants multiplied by 1 plus, because this is a growth model, so I'm adding to that 1 value, 0.03 to the x power. Or you can combine like terms and say that y is equal to 2,457 multiplied by 1.03, giving us our new change factor there to the x power. Both of these are acceptable formulas because they will go into the calculator the same exact way. Now, part B says, how many elephants are there going to be after 12 years? Well, I can say y equals 2,457 multiplied by 1.03, and I now just raise that to the third power to represent, or excuse me, the 12th power to represent those 12 years. In your calculator, you're going to enter in 2,457, open parentheses, 1.03, close parentheses. Then you need to use your exponential button, kind of looks like a top hat or like a little caret up arrow. And I'm going to put 12 as my exponent value there. And we're dealing with elephants here. We can't have parts of elephants, so I need to round to the nearest whole number. So my nearest whole number here is going to be 3,503 elephants. So how many elephants will it be in 12 years? 3,503 elephants. Let's move on to problem 9. It says a new 2010 Honda Accord was valued at $27,000. It depreciates at a rate of 14% each year. That depreciates is going to tell us that this is going to be a decay model. We're losing value here, which makes sense. You're buying a car. It's not going to gain value when you go away. It's going to lose value. So I have an initial value of $27,000 and a change rate at 14%. First thing I want to do is convert that 14% to a decimal. So that's going to give me a rate of 0.14. And I know that my decay formula is y equals a multiplied by 1 minus my rate, because I need to be less than 1. I'm losing value here, to the x power, where that x represents the time in years. So I have y equals 27,000 multiplied by 1 minus this rate of 0.14 raised to the x power. I can also rewrite this as y equals 27,000 multiplied by the change factor of 0.86 raised to the x power. Both are very acceptable forms of this exponential model. The next question says, what's the value in the year 2016? Am I going to put 2016 as my exponent value? No. I originally knew that it was a 2010 Honda Accord, and now we're in the year 2016. So to find the amount of years that have passed between there, I can say 2016 minus 2010. That gives me an x value of 6 years. So in my formula, I can say y equals 27,000 multiplied by 0.86 to the 6th power. This is money, so we need to round to the nearest decimal place. So I'm going to put this function into my calculator, make sure I'm raising it to the 6th power. And that means that after 6 years, this Honda Accord is worth $10,923 My calculator says 0.31535, so I'm going to round that to 0.32 because 5 will mean that I'm going to round up at the end. And guys, we're going to stop there for some of these because now we're going to go into compound interest after these two problems. So we're going to take a pause here, look at the next video to look at some compound interest formulas.